All right, hey, Algebra 2. We are moving from our ellipses, which we talked about last time, to hyperbolas. And I want to look at our equation first because I want to look at the similarities between first of all, our hyperbola and our ellipse equations, but also between the hyperbola vertical and horizontal equations. So notice that from our ellipse equations, still we have fractions, right? We have two fractions going on, and we have an a and a b, right? So what's different though is that in your ellipse equation, you have a positive sign here, plus sign. In our hyperbola equation, we have a subtraction sign. Okay, now let's look at the difference between these two. Also equals 1, right, all the time. Let's take a look at difference between the horizontal and vertical. Notice that your horizontal is going to be stretched vertically, and your vertical, or horizontally, your vertical is going to be stretched vertically, right, up and down, right and left, up and down. Notice the difference here. A and B don't change position, but your X and Y values are going to change position. So notice that your H and K are still going to be your center. And there's still a foci, and notice here that I've kind of dotted the foci there. It's actually going to be adding a squared plus b squared instead of subtracting like our ellipse. And think about that because our foci is going to be inside the hyperbola or on the other side of the vertices instead of on the inside of the ellipse. So what we will need to do for this time is we will need to graph our asymptotes. So that's going to be a little bit different than our ellipse. We didn't graph asymptotes for ellipses or circles, but we will for hyperbolas. So there's some steps there that we're going to follow for graphing hyperbolas. And let's go ahead and jump in, and we'll talk about what this slope means here when we get to those asymptotes. So our example number 1, let's look at it. It's y minus 1 squared divided by 9 minus x plus 2 squared divided by 4 equals 1. Now here's what we need to know, right? We need to know center, we need to know vertex, we need to know co-vertex, and then we need to know those asymptote equations or functions. So center is found just like in our circle and ellipse, but I want you to recognize, because I make this mistake too, is that your x values with your x and your y values with your y. So your center here is -2, +1. Vertex is still A, co-vertex is B, so we can identify those. A was always first, right? So A is 3, and B is 2. So notice what type of stretch it is. I'm going to look here at my standard equation. Since my y value is first, I know that it's going to be vertically stretched. So it's going to point up and down. So that helps us to know how we're going to draw that graph. So let's see. Our vertex, let's start following our, I'm going to draw it down here. I'm going to start following our steps on your notes to figure out how we're going to graph this hyperbola. All right, so our center is -2, +1. So I'm going to make that mark there. So it says locate the vertices. We did that. Let's do that now and put it on the graph. Since it is vertically stretched, my vertex is going to go up and down, right? It's going to be up 3, 1, 2, 3, and down 3, 1, 2, 3. So let's see, that's -2, 1, 2, 3, 4. And it's -2, -2, right? So those are my vertices. And then my co-vertex is right and left, and it's 2 this way and 2 this way. So I have 0, 1, and 1, 2, 3, -4, 1. So we have located our vertices, both vertices and co-vertices. All right, then it talks about using a dashed line to draw a rectangle. And this is what that means. We're going to basically draw a box for our asymptotes that we're going to draw together. So here's our little box. And this is going to help us know, the asymptotes are going to help us know how wide or skinny our hyperbola is going to be. So here's our asymptotes. To find the slope of our asymptote, it's going to be b positive or negative b over a, right? So our slope in this case, b was 2, a is 3, my slope is 2/3, right? Now here's my equation for my asymptote. Y equals k plus or minus b over a times x minus h. So thinking about why it's plus or minus, it's because you're going to have two lines, right? We want to have one line that goes this way and one line that goes this way. Well, they're going to be the same, they're going to have the same slope, just inverses of one another, right? So that's why it's positive or negative 2/3 here, positive or negative 2/3 here. So let's plug this in. I have a positive 2/3. What was my k? My k is 1, x minus negative 2, which is a positive 2 here. So let's multiply this out. Well, or we could just leave it. It doesn't really matter, but I like to multiply it out. So we have 2/3 x plus 4/3 plus 1. I just moved it over here so we could put these together. So if this is 3 over 3, I have 7/3. So the equation of one of my asymptotes is y equals 2/3 x plus 7/3. Now we should do the negative one, right? So it's y equals 1 minus 2/3 x plus 2. Guess what? It kind of looks the same. Equals 1 minus 2/3 x minus 4/3. So let's put that 1 and that 4/3 together. Y equals negative 2/3 x minus 4/3 plus 3/3. So it's what, a negative 1/3, right? All right. So we have both of our asymptote equations. That's a lot of work, right? But we need to know what this, what our asymptotes look like. So let's draw these here. They're going to be dashed because they are asymptotes, right? They're not part of the equation, but they help us to know how fat or skinny that hyperbola is going to be. All right, now we can draw our hyperbola. We know these are our asymptotes, so we can go ahead and say, okay, this is vertically stretched, so I know it's going to be up and down, right? All right, there you go. One example down. All right, let's look at what's next. We'll do B and C together when we get into class. Let's look at example 2. All right, let's work this through this example 2. It says that our vertices are -4, 0, and 4, 0. And our asymptotes are y equals 2x and y equals -2x. All right, so let's think about what we need. We're going to be writing the standard form of the hyperbola. And we need to know the center and vertices and co-vertices, right? Well, we have vertices, but we need to know A, B, and then H and K, right, in order to write our standard form. So since we have the vertices, we do know that our center is right in the middle of those vertices, right? So think back to what we have been doing to find our center before. We're going to use the midpoint formula, right? So average in your x's, average in your y's. So let's take our vertices, -4 plus 4 divided by 2, and 0 plus 0, this is looking pretty good. Looks like our center is going to be 0, 0. So that's our center. Now we need to find our A and B, right? And we need to know whether it's going to be vertically stretched or horizontally stretched, because that's going to tell us what our standard form is. Well, if my x's have changed, right, then, and these are my vertices, then it's going to be horizontal. So I know that we're going to use this standard form of our equation. X minus h squared divided by a squared minus y minus k squared divided by b squared equals 1. All right, I do know my center and I do know my vertices, so I need to know, I'm going to find A by finding the distance between my center and my vertices, right? So I'm going to use the distance formula. You can probably look at it and know what the distance is, but we're going to use our formula. D equals y2 minus y1 squared plus x2 minus x1 squared. All right, y's 0 minus 0, x's 0 minus 4. So we have 0 plus 16, and the distance is 4. So I know that my A value, so our center is 0, 0. My A value is 4. And now we need to know our B value. Well, that's good because we know our asymptote is y equals 2x and y equals negative 2x. Well, if our slope for our asymptote is b over a, then I can just find that by doing that, right? If slope is 2 and a is 4, then we can find b by just multiplying, right? So b here is 8. Great. So let's go ahead and write the standard form of our equation. We have x minus our h, which we know is 0, divided by a squared, 4 squared, minus y minus 0 squared divided by 8 squared equals 1. So let's see, I can cancel those out. X squared divided by 16 minus y squared divided by 64 equals 1. All right, there's your standard form of your equation. Nicely done. All right, we'll do the rest in class together.